All right, boys and girls, on this video, we're going to talk about equivalent fractions and what equivalent fractions mean. Equivalent fractions really should not be new to you. You learned a little bit about equivalent fractions last year as fourth graders when you were comparing fractions, when you were thinking about as a fraction greater than or less than or equal to. Well, the whole equal to part that you learned about last year was basically saying, well, this fraction is equal to the other one. And so you really should know what the word equivalent means. The word equivalent means equal or the same. And so if you have equivalent fractions, ultimately you're trying to find a fraction that has the same value as the other. So when you get to fifth grade, there are a couple of ways that we really focus on when we try to find what are called equivalent fractions. And usually when I start teaching this in my class, we start taking notes. I kind of tell my students, look, there's two ways to find equivalent fractions. They're kind of two most common ways that you see in your classrooms are going to be, you're going to use multiplication to find equivalent fractions, or you're going to use division to find equivalent fractions. And so it's going to be kind of weird at first because it is such a new skill to you, but gosh, we do this skill so much that it will become second nature. And by the time you get into 6th, 7th, and 8th grade, this skill is going to be something where it's kind of like your math facts are now. Your math facts should just be natural to you. You should, not be stumped by a math fact, by a multiplication fact. Well, as you get older, your equivalent fractions should be that way, and it should just be kind of second nature, and it should just kind of flow, and you should know this really easily. So I'm going to take you through both ways to find equivalent fractions in this video. Probably out of the two, multiplication is not used as much, but it's still important. The division one, which I'm going to be referring to as something else here in a second, is the one that shows up a lot, and it shows up for a while, meaning that you kind of start working on this in fifth grade, and this is a skill that you might use technically all the way through college level math, really. And so this is something that is very important and that you guys get a good foundation and a good start on it in fifth grade. Okay, so I'm going to start with the two fractions that are on the page. The top fraction, 2/3. I would want to ask kids, well, okay, well, what do we know about 2/3? And so we might have that conversation, and a lot of kids would go, okay, well, 2/3 is, there's two parts out of three. Or our kid might say, well, 2/3 is approaching a whole. It's 1/3 away from being 3/3, which is a whole, which that would be great to know. What I would want a kid to see or to realize is, since it is 2/3, and if we want to find an equivalent fraction for it, we want to find something that it's equal to. It's going to be the same fraction. Because of it being 2/3, our only option on 2/3 is to use multiplication to find an equivalent fraction. So I'm going to write a multiplication symbol next to it, and then we're going to talk about this next process because this could be kind of weird. So when you multiply a fraction to find an equivalent fraction, what you're trying to do is you're trying to multiply it by a whole. Now, hear me out here. This will make sense if you really think about this. So if we're multiplying it by a whole, that means we're going to pick a fraction that represents 1. Well, fractions that represent 1 are the same numerator and the same denominator. So I think if I write it, it would make more sense. So I'm going to write the fraction 2/2. Which technically, if I were to put like a box around this, it kind of looks like a box down. It kind of looks like a number 1. Well, when you're taking 2/3 and you're timesing it by 2 over 2, technically you're timesing it by 1, which the reality behind that is, what you should know by now, is anything times 1 is itself. And so it's almost like we're going to take 2/3 and we're going to times it by 2 over 2. We're going to get this different fraction. Technically, the fraction that we get is going to be the same. They might have different numbers, like the numerator and denominator are going to change, but technically it's the same fraction. So how this works is really simple. It just kind of falls back on multiplication facts. I'm going to go across, and I'm going to draw some arrows here so you can kind of see my thinking. I'm just going to multiply across, and I'm going to come up with my new fraction. So 2 times 2 is 4. And 3 times 2 is 6. And so I'm going to get this new fraction of 4/6. Okay, well, the reality is 4/6 is the same thing as 2/3. They're equivalent. They're the same thing. And I could draw this. I'm not the best artist in the world, but I think I could draw something here that would at least make sense in y'all's eyes if you're not really seeing what I'm doing here. If I were to draw 2/3, I could draw a fraction bar here, and I could cut it into 3 pieces, and I could shade 2. Or I can draw the same fraction bar underneath, and I can cut it into those same 3 pieces. But now, if I wanted to, I could cut it in half, which would give me 6 pieces. And if I shaded 4 of them, really and truly, if I compare the 2 pictures, the same thing is shaded. It looks different because it has different parts, but really and truly, it's the same. It's equivalent. It's equal. And so the kind of neat thing about this is what I tell my students. The kind of neat thing about this is you can pick whatever number you want to multiply it by. You could do 2 over 2. You could do 5 over 5. You could do 8 over 8. As long as it's 1. Now, the one that you probably wouldn't ever pick, and I always would have kids that would say this, well, what about 1 over 1? Well, you wouldn't want to pick 1 over 1 because you just get 2/3 again. Okay, what about 0 over 0? Well, that's nothing. That doesn't make any sense. We don't want to pick 0 over 0, but you want to pick a number that has the same numerator and denominator. And so a lot of times what I tell my students is, we'll keep it simple. Let's do 2 over 2. 2 over 2 is easy. 2's are easy to multiply. But the point that you have to get from this, the math that you have to take away from this, is you are trying to find something that is equal to it, that you could go and draw it out. It would be the same picture, and it has the same value. So 2/3 and 4/6 are equivalent to each other. If we had picked 5 over 5 instead of 2 over 2, we would get a different answer. We wouldn't get 4/6, but we would find another equivalent fraction. And so it's just kind of like it's one of those things when you're in class and when you're learning about this in the next few years, it's going to get so easy for you that you won't even think about it. Now it's kind of weird because it's new, but the math behind this really and truly is just math facts. It really is. That's why math facts are so important. So I'm going to put a little squiggly line just to kind of separate the page here. So that's one way you can find an equivalent fraction. You can multiply it by a whole, or 1, and as long as the numerator and denominator are the same, you will get an equivalent fraction. Okay, so that's one way. The second way, and I said this at the beginning, was using division. So I'm going to take this bottom fraction of 10/12 and I'm going to divide. Now, this is something that, most teachers, when they start teaching this, and I'm kind of bad about it too sometimes, but most teachers, they'll probably catch themselves and they'll say, okay, we're going to divide. But technically, a better term for this is what's known as simplifying. You're going to simplify this fraction. Simplify basically means we're going to divide. What we're going to do is we're going to take kind of the same thought process that goes on up top. We want to find a whole to divide it by, meaning we want to find a same numerator, same denominator to go and divide it by. So I'm going to kind of have the same thought process going on here. I'm going to have kind of like a whole sitting there. I'm going to have the same numerator and denominator. Now, here's the thing. When you see these fractions, you have to stop and think, okay, well, what is a number that can go into both the numerator and denominator? So like up at the top, when you're multiplying, really and truly, you can just pick any number that you want to other than 1 over 1. When you're simplifying, though, you have to pick a number that goes into both. For example, on 10/12, if I'm thinking about a number that goes into both, I want to think of a number that, again, it can't just go into one and not the other one. So I sometimes would have a kid go, okay, I think I kind of get this. What about 4 over 4? Okay, well, here's the case. 4 can go into 12, but 4 can't go into 10 equally. It's not a math fact. So if I look at 10 and 12, I'm thinking maybe the only thing that can equally go into both is 2 over 2. 2 can equally go into both of those. So I'm going to go and I'm going to divide it by 2 over 2. Again, this kind of goes back to math facts, though. 10 divided by 2 is 5. 12 divided by 2 is 6. And so now I have an answer of 5/6. 5/6 is the same thing as 10/12. They are equivalent. I'm not going to draw that one out, but I could if I wanted to. I don't think I have enough space here. But if I wanted to, I could draw 10/12 and I could prove that it is the same as 5/6. And so it's just kind of one of those things where, you got to get a lot of practice in for this for it to kind of start clicking. What is going to help with this is knowing the lesson that we just left, which was factoring and finding GCFs, greatest common factors. Here's the connection that you can make between simplifying and GCFs. So if you were to factor 10 and factor 12, it would look something like this. So I'm going to do this pretty quick because I feel like it should be pretty quick. These are low numbers. These are not difficult numbers. If you know your facts, it would look like that. Well, the fact of the matter is, if you show your work and you look here between 10 and 12, your greatest common factor is going to be a 2. And that is what we use to simplify by. And so all those, you got to think about what we've been doing in math lately. If we're going to learn how to factor and we're going to learn how to find greatest common factors, this is really the reason for us learning that. You're trying to use your skills now to go, okay, well, if I have a fraction like 10/12, I know that 2 is going to go into both, and that's something I can now use to simplify this fraction. And so, again, it's a lot to take in. The more you see it, the easier it gets. Practice makes perfect. I don't know how many times I tell that to my students, but it's so true. And the more you do it, the more it'll start clicking and the more it'll make sense. And so really this page here, it's only 2 examples, one for multiplication, one for division. But what I always tell my students is the math is not going to change. The numbers will change, but the math is not going to change. You would still, I could put up another fraction and I could see what type of fraction that was, and I could think, okay, is this something where I could multiply to find an equivalent fraction, or is this something where I could simplify to find an equivalent fraction? The big picture here, though, is when you're finding those equivalent fractions, no matter how you do it, whether it's multiplication or division using simplifying, you're still in your mind. You're thinking about what's taking place. You are finding a fraction that has the same value, and that's really important as you get older. And you'll see why, and you'll understand it more as we get further into the year. But this skill here is extremely important. It's very important that you understand what's happening.